Students will be able to use identities to simplify trig expressions. We start out with the reciprocal and quotient identities, which is really nothing new for us. So sine is the reciprocal of cosecant, cosine is the reciprocal of secant, cosecant is the reciprocal of sine, and so on. Over here we have tangent is sine over cosine, cotangent is cosine over sine. So on letter A, it says if cosecant of theta is equal to 7/4, find the sine of theta. Well, cosecant and sine are reciprocals of each other, so the sine of theta must be 4/7. Now on letter B, it takes a little bit more math to get this answer, but it says cotangent is 2/5 square root of 5, and sine is square root of 5/3. So we know that cotangent of x is equal to cosine of x, cosine of x over sine of x. Well, we know the value for cotangent is 2/5 square root of 5, and we know that sine is square root of 5/3. So we have cosine of x over square root of 5/3. Well, now we can just multiply both sides by square root of 5/3. So we're going to multiply by square root of 5/3. So cosine of x is equal to, the square root of 5's cancel out, and on top we have 2, and on the bottom we have 15. So 2/15. Here we have the Pythagorean identities. And if you take sine squared plus cosine squared is equal to 1, and if you divide by cosine squared theta, you get this right here is tangent squared, which is right there. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. Then if you do the same thing except divide by sine squared, you get 1 here, which is actually that one. Cosine squared over sine squared would be cotangent squared, and 1 over sine squared is cosecant squared. So you can get the other two from the first one. That's kind of a mess. I'm going to erase that. Find the value of each expression using the given information. So this says find cosecant and tangent if cotangent is equal to -3. So the Pythagorean identity I see with cotangent is right there. So cotangent squared, which is 9, plus 1 is equal to cosecant squared theta. So cosecant squared theta is equal to 10. So cosecant of theta is equal to plus or minus the square root of 10. Well, if cosine is negative and cotangent's negative, then sine must be greater than 0. Sine must be positive. Now cosecant is the reciprocal of sine, so cosecant of theta must be positive square root of 10. Because if sine's positive, then cosecant, its reciprocal, must be positive. And let's see, they tell us what? Well, if we know cotangent's -3, then tangent is equal to -1/3. They are reciprocals of each other. We have cofunction identities. Sine is cosine shifted. So sine is cosine of pi/2 minus theta, and you can see we have the same relationship for a lot of these. Tangent, cotangent, and even secant and cosecant are just, you can get the other one by just shifting the other. Odd and even identities, sine is an odd function. So if we graph sine, it looks like this. And it's symmetric over the origin, that's odd. So sine of negative theta is equal to negative sine of theta. Cosine is an even function. It looks like this. It's symmetric over the y-axis. So if you have a point here, go over the y-axis, we have a point there. Cosecant is odd, secant's even, tangent is odd, and cotangent is also odd. So if tangent equals 1.28, find the cotangent of theta minus pi over 2. Well, we have theta minus pi over 2, but what we want is pi over 2 minus theta. So this is backwards. So let's do this. Let's go cotangent of negative pi over 2 minus theta. So it's like we factor out a negative. Well, it turns out that cotangent is an odd function. So we can write this as negative cotangent of pi over 2 minus theta. Now the reason we can write that is cotangent is an odd function. Well, cotangent of pi over 2 minus theta is the same as tangent. So we can replace this with tangent. We have negative tangent of theta. So this is actually the opposite of this. So our final answer is negative 1.28. Simplify by rewriting using only sine and cosine. Well, secant is 1 over sine. Secant is 1 over cosine. And cotangent is cosine over sine. Let's see. So now these are two fractions. So it's really 1 over sine cosine minus cosine over sine. So now let's get common denominator by multiplying this by cosine. Cosine. So what do we get? We get 1 minus cosine squared over sine times cosine. Well, 1 minus cosine squared, let's look at that. If we back, I think we got to back up right down here. If we minus cosine squared from both sides, we get sine squared is equal to 1 minus cosine squared. So we can replace 1 minus cosine squared with sine squared. So let's go back. There we are. 1 minus cosine squared is the same as sine squared. And we're over sine cosine. So next, we can cancel this sine with one of those sines, and we're left with sine over cosine, which is tangent. Simplify by factoring. Here we have sine squared x times cosine x minus sine of pi over 2 minus x. Sine of pi over 2 minus x. Well, that's exactly cosine. So we can replace this piece right here with cosine of x. Now we can factor out a cosine. Sine squared x minus 1. There's the factoring part. This piece right here is backwards, but we can take a negative out of that. And we write negative cosine of x, 1 minus sine squared x. Well, 1 minus sine squared x is cosine squared x. So this ends up being negative cosine to the third x. Example 6, simplify by combining fractions. Let's multiply the top and the bottom of this fraction by cosine of x, and then we're going to multiply the other one, the fraction to the right, we're going to multiply by 1 minus sine of x on the top and the bottom. So we're going to get common denominator. So both denominators have a 1 minus sine x, and both now have a cosine. On top, we get sine of x times cosine squared x. And then on the other side, we get 1. So minus, let's put in parentheses, 1. Outside is minus sine x. Inside is positive sine x. Those cancel out. And then last is minus sine squared x. That's going to be all over cosine of x times 1 minus sine of x. This right here is the same as cosine squared x. So on top now we have sine of x cosine squared x minus cosine squared x. All over cosine x 1 minus sine x. On top now we can factor out a cosine squared. So cosine squared x times sine minus 1 all over cosine of x times 1 minus sine. So these two are opposites of each other, which means they're going to leave a negative when we cancel those out, and then this cosine cancels one of those. So we end up with negative cosine of x. Rewrite to eliminate fractions. Rewrite this as an expression that does not involve a fraction. Well, we're going to use conjugates to do this. So we have 1 over 1 plus cosine x, and we're going to multiply the top and the bottom by 1 minus cosine. 1 minus cosine x. So on top we have 1 minus cosine of x over, first is 1, outside is negative cosine, inside is positive cosine. I should have just told you those cancel, that's all right. And then last is minus cosine squared x. And we can see in the middle, those cosines are going to cancel out. So now we have over 1 minus cosine squared x. Well, the bottom is the same as sine squared. 1 minus cosine x over sine squared x. Now we can go do like reverse common denominator. We have 1 over sine squared x minus cosine over sine squared x. This right here is the same as cosecant squared x. And then on this one, we might, do we have some choices? Yeah, we have some choices. I could make this cosine of x times 1 over sine squared is cosecant squared. So cosecant squared x. So that's one option. The other option is I could split the second one up into cosine over sine times 1 over sine. So this would be cotangent. So I could have cosecant squared x minus cotangent x, and this is actually times cosecant x. Now the instructions say to rewrite this as an expression that does not involve a fraction. And neither one of these involves a fraction. So I would take either one as an answer.